Hello and welcome to this motorBench Development Suite tutorial. Today we will learn how to use motorBench Development Suite to generate code for your motor control application. Before we begin, here are the system requirements that you should meet. You should be running MPLAB-X IDE version 5.30 or later. If you are using a DS-PIC33 EP device, you should use the XC16 compiler with version 1.36 or higher. If you're using a DS-PIC33 CK device, then you should either use XC16 version 1.50 or later, or you should use XC16 version 1.41 with a device family pack, version 1.2.66 or later. The firmware itself has been tested with XC16 version 1.41. MPLAB Code Configurator version 3.95.0 or later, and PIC24, DS-PIC33, PIC32 library version 1.166.0 or later. The latest MPLAB-X, IDE, and XC16 compiler can be downloaded and installed from our website at microchip.com/mplab/mplabx, IDE, and microchip.com/mplab/compilers, respectively. After we have installed the IDE and the compiler, we will install the MPLAB Code Configurator plugin. To do so, open MPLAB-X and go to Tools, Plugins. Under the Available Plugins tab, select the MPLAB Code Configurator and click Install. The installer may ask you to restart MPLAB-X. Once you are done installing, or if you had already installed MCC before, you should see it under the Installed tab in the Plugins window. Now that we have our environment set up, we can begin creating our project. The best place to start is by downloading sample projects from our website. Go to microchip.com/motorbench and under the Documentation tab, click on the Sample MPLAB-X projects for motorBench Development Suite 2.25. This will download a zip file to your machine. Once you extract this zip file, find the project that most closely matches your hardware and open it in MPLAB-X. For this demo, we will choose the Sample MB33 EPMCL V2 project. Now in MPLAB-X, right-click on this project and open Project Properties. Here you must choose the hardware tool that you have connected to your board. To be able to run motor parameter measurements, which we will do shortly, you must use either ICD3, ICD4, or Real ICE. Click on the MCC button to launch MCC. motorBench Development Suite should already be added to your project resources. This is also a good opportunity to verify whether you are using the appropriate PIC24, DS-PIC33, PIC32 library version. To do this, expand the PIC24, DS-PIC33, PIC32 MCU's entry. The version that has a green checkmark beside it is the currently loaded version. Make sure that version is greater than or equal to 1.166.0. If it is not, right-click on a version that meets this requirement and click Mark for Load, and then click Load Selected. You are now ready to begin configuring the motorBench Development Suite library. When you load motorBench for the first time, motorBench will request for you to complete registration. Registration instructions can be found in the How to Get Started section on the motorBench website at microchip.com/motorbench. For registration on an offline machine, please contact motorBench support at microchip.com. Once registered, you should see an editable homepage in the center and a non-editable summary view on the bottom left. You will navigate between the Configure, Tune, and Customize stages as you progress. In the Configure stage, first make sure that you have selected the appropriate board. If you started with the correct sample project, the appropriate board should already be chosen for you. Then, click on Import Motor. Currently, we provide templates for the low-voltage Hurst 300 and high-voltage Leadshine 400 motors out of the box. For this demo, we will import the Hurst 300 motor. If you are using a different motor other than the Hurst 300 or Lead Shine 400, then import one of these two motors to begin with and update the motor nameplate data. You can also export this motor so that you may import it the next time. Exporting a motor will export the active motor parameters along with it. To perform parameter measurements, click the Measure Now button to open the Measure pane. In the Measure pane, select the COM port your board is connected to. This pane has two main parts: board calibration measurements and motor parameter measurements. The calibration step is optional, and we recommend that you run it at least once every time you make a change to the development board, because incorrectly switching calibration and measurement hardware can cause high temperatures. Please read and acknowledge this warning. To run the calibration step, connect 3 resistors of the same value to the output of the motor control board's inverter stage. Now click this radio button to acknowledge hardware connections and enter the resistor value. The calibration bus voltage is the same as the output voltage under Configure, Board, Voltage Source. Verify that this value is correct and click Calibrate. To run motor parameter measurements, connect the motor instead of the calibration resistors. Mark your hardware changes in the Measure pane by selecting I have disconnected the calibration board radio button and I have connected the motor checkbox. Verify the max motor speed, spin down time, and current controller settings and click Start. Icons beside each parameter will show you the status of the measurement. An unsolved puzzle icon is for a parameter that is yet to be measured. A clock icon is for a parameter that is currently being measured, and a solved puzzle icon is for a parameter that has been measured. Once measurement is complete, the measured values will be populated in the Composer view in the center. If you like the measured values, don't forget to click the Use All button. This will cause the active values to be updated. Note that only the active values are used for code generation. Tune is an optional stage that gives you the opportunity to tune the system to meet performance specifications by changing the current controller and velocity controller values. For the Hurst 300 motor, the default current and velocity controller values are adequate, and you may skip this step. Customize, too, is an optional stage. It exposes parameters that can be useful for advanced users. The Show Parameter Descriptions option, along with the library help and the MCAF User's Guide, provide information on these parameters should you need to configure them. The Generation Readiness status on the top left changes to Ready to Generate as soon as your configuration contains the minimum data required for successful code generation. Usually that means as soon as you complete the Configure stage. To generate code, click the Generate button on the left in the Project Resources area. The output window on the bottom shows the generation status for each generated file. If all of them generate successfully, you are now ready to close MCC, build your project, and program your device. Thank you for watching this brief tutorial on how to use motorBench Development Suite to generate code for your motor control application. For more information, please visit microchip.com/motorbench.